Hello friends. Today we will going to discuss about quicksort, which is the sorting algorithm in data structure. If you know somehow computer science, then you can really know that how the sorting techniques are important for any computer engineer. Because any sorting, searching, all this type of data structure requires in day-to-day coding. So we will discuss about quicksort in this video. So let's begin. So first of all, what is quicksort? So quicksort basically works on a principle of partition technique. An array is given, and that array in that array we choose one array element, and that element we consider as a pivot. If if we if you know that what is a pivot is a element around which the object is conditioning, like in mechanicals. So for example, in such a way we create a pivot element. For example, if we have array 1 2 3 4 5 6 7 8, this is already sorted array. So if you want pivot as 2, then around that element we will going to discuss how the other elements are going to arrange, because as a result we want the fully array which is to be sorted. That is our main goal. So before coding, uh, I'll tell you about how this logic is work. First, we select a pivot, and according to that pivot, the left side should be the less than that of the pivot, and the right side should be the greater than that of the pivot. For example, we have if we have an element 7 6 1 2 3, then 1 is a pivot. If we consider, then 2 3 should be on the left side of that 1, and 6 7 will be on the right side, because those are the greater element, those are the greater in value elements. So likewise we have to code in such a way that our array sorted in n log n time. Why n log n time? Because there is n log n search tree and n elements are given, so n into log n time complexity required for that particular array to sort. So let's begin with the coding. So first we require the partition function. So let's give that as a name part. In that particular part, that is a partition, I think I should give a full name. Okay, partition. So in that partition function, we first take the array, that is pointer array, then the least value of that least index of that particular array, which is int p, then the highest index of that particular array. This is my function. And then what we require, the main function, the quicksort function. So quicksort function we have to take as a pointer. I'll tell you why. In this particular array we require, in this particular function we require array as a pointer, then again same thing, lowest index and the highest index. So this we declare our function, we have to define it. Okay, so let's first discuss the quicksort function and write the code. So quicksort function is a recursive function, although we can do it by using a while or a for loop, but recursive may have some more hunch than the while and for loop, because it requires a less time and less space, because it uses a recursive calls to recall the function. So first we put a condition, that is p is less than q. If this is true, then we take r as a partition and we pass array to that partition, list element and highest index. That's it. We take a partition. I'll tell you later what the partition actually do and how actually it will solve the problem of sorting. I'll tell you. So then we have to call it recursively for the first half of, because partition give you the fixed pivot, and left hand side and right hand side we have to solve using recursive function. So in left hand side we pass again array, the first point, the lowest index, and in this time we have to pass the point partition less than 1, because we partition the element, and at the pivot less than that one point of that pivot, we take a whole another array. So that whole another array treat as a queue, means my r minus 1 is my queue actually, and that r which is I'm getting partition, it is the element which is already sorted in the previous recursive call. And the right hand side, how we solve? Qs r array, sorry, then r plus 1 and then q. So this two recursive call, by using splitting method, that partition method, automatically sorted the all array, and at the end we return the array because we want a sorted array. That's it. This is a function. So now it's time to look to the main heart of this code, that is partition. So basically partition, what it does is actually create a partition in that particular array, small partition in that array, so that we get the pivot element, we enlist the all other elements to the left and right hand side of that particular pivot, and again we do this recursively until and unless we get the array sorted. So how we do? Let's see. First we require I, which is to be the main index which traverse throughout the array, which is actual pointer. So we allocate this index to the p. Then we want x. This is our element, which is the pivot element. More often, the first and the last element or the middle element can be considered as a pivot. I'm here consider my first element as my pivot. There are some other points also. There are two conditions when this partition function, by deciding the pivot element, decides the time complexity of the algorithm. For example, if the partition element is highest or lowest in value, then that particular algorithm takes n square time, big of n square time. And if that particular partition function, if it consider the medium value, then it takes n log n time. So there are two cases, best case and worst case scenario. So for now, I consider my first element as my partition element, and then the main logic, that is I have to create a loop because I have to go through it array iteratively. So I want to create a loop in such a way that I have to compare first element with the pivot, second element with the pivot, third element with the pivot, and so on. And by comparing those elements with my pivot, I can decide whether it goes to the left or right hand side of the pivot. That's it, all together the story of this partition function. So let's code the partition function. So int j is equal to, it starts with p plus 1 because we are already in the ith position. As you see on the second line, that is I is equal to p. It suggests that I is equal to p means we are on the lowest index, and j is equal to p plus 1 means we are on the second position. So j less than q, j plus plus, we have to iteratively pass through the elements. And in that particular case, if my array of j is less than x, means my arrayth element which is on the jth position, those are the less than my pivot element, then automatically we have to increment the ith position, it closes to the jth, and then swap happens. So swap array of I comma array of j. So this is swap happens at the time when pivot element actually greater than the founding element, that is array of jth position element. If that is a smaller than my pivot, then for sure sorted is to be left on the array or to the pivot. So that array of j element will be on the left side of that pivot, and if it is not, then we go out of the if loop and just further things are going to happen. So for example, out of for loop, one swap function run which swaps the array of I and array of p. So that is the final swap, and this swap decided the original position of pivot. This swap decided original position of pivot. For example, if there are elements 3 4 5 1 2 and my pivot is 3, then my 3 has to be going to the after 2, means 1 2 3, then 3 will come, after 2 3 will come. So after this swap, the element automatically come to its original position, and array going to splits into two different sorted arrays, sorry, unsorted arrays. So that's why I have to return array of return I. So this I return, which is going into the R in the quicksort function, which is you see on the below, and that are going to create a partition into the quicksort function. So that's it. So just check for the, we have to check the function. So we have to create one array. I'll create 6 4 3 2 1. So this is random array, unsorted array. Okay. So if I want to sort this array by using function, then I have to create one pointer p, and that pointer p I have to assign to the quicksort and pass to the array. The lowest position is 0, the highest position is 5th. Fifth position is highest. So array comma 0 comma 5. So lowest position, that is lowest index comma highest index. And then I have to go into the for loop so that I can print this array. That is p of I. That's it. So let's do it now. We have to check the code, we have to run it, and then we will see that any bug is coming or not. Just wait for a second. So as you see on the screen, 1 2 5 3 6 7, the code runs, but we got one defect, that is we have to we got first 3 and then 5, so that is incorrect, so we have to debug the code. Okay, then let's discuss where we gonna wrong. Okay, let's check another input to the system. Whether it is going into worst case scenario or not, we have to check that. So in this worst case scenario, it is showing right answer. Okay. Let's check this input. We have to go through so many inputs that then we can know what is wrong with the code or not. Anything is wrong. Okay, that's it. I think code is running well. So thanks to watching the video. Stay